The topic I will be covering today is the addition of reactions and their delta G naughts and spontaneity. The problem asks us to add reactions A and B, show the net result and delta G naught of the coupled reaction under standard conditions, and determine whether it is spontaneous or not. Reaction A is glycerol plus hydrogen phosphate going to products to form glycerol 3-phosphate plus H2O. The delta G naught of this reaction is positive 9.2 kilojoules. Reaction B is ATP plus H2O going to products to form ADP plus hydrogen phosphate plus a hydrogen ion. The delta G naught of this reaction is negative 30.5 kilojoules. To solve this problem, we need to know that the delta G naught is the change in Gibbs free energy at standard conditions, and if the delta G naught is positive, then a reaction is not spontaneous, but if the delta G naught is negative, then a reaction is spontaneous. When we are adding reactions, we want to get rid of terms that are on both sides of the equation so that we don't include intermediates or catalysts in the net reaction. Here we can see that reaction A is the phosphorylation of glycerol, which is a necessary step in forming phospholipids in cells. And reaction A has a delta G naught that is positive, so we can tell that this reaction is not spontaneous. Reaction B is ATP hydrolysis, and it has a delta G naught that is negative, so this reaction is spontaneous. To add the reactions, we want to add all of the reactants and all of the products. Here for reaction A, we add glycerol and hydrogen phosphate, and for reaction B, we add ATP and H2O to get the reactants for the total reaction. The total reaction has glycerol plus hydrogen phosphate plus ATP plus H2O. Now we want to add all of the products, so we add glycerol 3-phosphate plus H2O for reaction A and ADP plus hydrogen phosphate plus a hydrogen ion for reaction B to get glycerol 3-phosphate plus H2O plus ADP plus hydrogen phosphate plus a hydrogen ion for the total reaction. Now we want to cancel the terms that are on both sides of this equation. Once we do this, we get rid of hydrogen phosphate since it is on the reactant side of reaction A and on the product side of reaction B. We do the same thing for H2O because it is in the reactant side of reaction B and on the product side of reaction A. Once we've gotten rid of the terms that are on both sides of the reaction, we have the net reaction, and this is glycerol plus ATP going to products to form glycerol 3-phosphate plus ADP plus a hydrogen ion. So here we can tell that at a 1-to-1 ratio, reactions A and B were able to cancel the terms that were on both sides. And now we can go on to the delta G naughts. So we add the delta G naughts. So delta G naught for reaction A is positive 9.2 kilojoules added to the delta G naught of reaction B, which is negative 30.5 kilojoules. We have a net delta G naught of negative 21.3 kilojoules. The net reaction problem solution has a net equation of glycerol plus ATP going to glycerol 3-phosphate plus ADP plus a hydrogen ion. The delta G naught of this reaction is equal to negative 21.3 kilojoules, and since this delta G naught is negative, this means that this reaction is spontaneous. So the conversion of ATP to ADP, which has a negative delta G naught, was enough to make the reaction that couples it, ATP hydrolysis, with glycerol phosphorylation into a spontaneous reaction, despite the fact that the delta G naught of the glycerol to glycerol 3-phosphate reaction is positive.